Hello everyone, welcome to this new video. So before we proceed further, I would like to wish you all a very happy Bogi. So this festival basically asks you or requests you to burn your anxieties, burn your confusions, burn your doubts, burn your misunderstandings, and burn your failures, burn your unfaithfulness, burn what are the mistakes that you have done so far, or burn the difficulties or the depressing moments that you're carrying on your head. Burn all those things that you're making you feel low in your life. So this is a phase, or this is a point of time you are entitled to start something new. Okay, so this is an auspicious moment where you can actually plan for the better things in your life, right? So start new, live new, love new, enjoy new. Okay, this is the main aspect of today's day. So bogi and lahari, so lori, sorry, so the way it's termed is different in different parts of India, but the original meaning remains the same, right? So as as a well-wisher of all of you, I would like to request you people to please start a new phase of life and take this moment as an auspicious moment. Take blessings from God, take blessings from the nature, right? So be happy, try to inculcate some new things in your life that could actually add a it'd be like a value addition to you. Fine. So let us go with the problem today. So the problem says, given a Boolean matrix of size R by C, where each cell contains either 0 or 1, find the new row numbers of row which already exists or repeated, right? It's very pretty, straightforward. The question is very, explanatory, self-explanatory. So these are some of the examples given. If you can see from example 2, like is basically the question basically is asking about if you can find the same row appearing once again. So take the note of that index. Okay, so finally give out a vector, output a vector that has all those indices. Okay, so this is the task, and expected time complexity is O of R, I mean R by C, and auxiliary space is also R by C, and this is the most optimal one, and we are following the same thing. Fine. So and also the company tags of this question are Microsoft, and the topic tags are matrix. So try is like, if you people would have solved this problem, I mean gone through the concepts of try, you would have easily solved this, because try basically works like that only. The dictionary data structure, so it takes every point into note, every the total word in, like it's like a total word that's going to be hung as a branch to the tree. So the same concepts you can even use to solve this question, but instead of complicating things, because not many of you will be knowing try concept, I'll soon launch a playlist just to explain the video concepts of try. I will very soon do it. So but before that, because I think majority of you might not be knowing that, so that's the reason we have solved that in using an unordered set, right? So I hope it's clear. And in this case, the space complexity is not O of R by C in our solution. It's much more optimal. It's just O of C. Okay, so because in the worst case we are storing in O of R, sorry, in the worst case we are storing like R results. So I'll even explain you what is the logic that we are actually doing. So going through the example that has been given. So in this particular example, if we clearly observe, so where number of rows are 4 and columns are equal to 3, the output is equal to 1 3. Why is that so? Because the first index row is 1 0 0, and that has already been appeared at 0 0th row, isn't it? So this is a duplicate row. And coming to third row, that is 0 0 0, that has already been appeared in the second row. So that's the reason this is also a duplicate row. So wherever you find a duplicate rows, put that indices into your particular vector, final vector, and return that, right? So first index and third index, whatever the row that you're having there, those are duplicates. That means that have already appeared before. So that is the basic expectation from the question. That is the output that you need to return. Now what is the approach to solve this question? So very first thing that I would like to highlight is the brute force approach. Okay, the brute force approach. What is the brute force approach? So the brute force approach is, so you'll be standing on this particular element first, right? You'll be standing on this particular one, right? Once you'll be standing there, you'll be comparing this one with the next the below row, and you'll be comparing this with this with element, this element with this element. And once you have come to the end, if you find that there is no other disturbances, or there is no instance like not equal or inequality, that means you'll say that this particular row is a duplicate row. So that's the reason you'll put this index into your final answer, and then you'll come to this particular row and compare the 0th row and this row. And once you're done with that, you'll be coming to this row and compare that with 0th row. So you'll be taking this this as the reference. Okay, you'll be taking this as the reference and you'll be comparing all the rows below it. Once you're done with that, now you'll take this one as your reference and you'll compare all the ones the rows below it, right? So that is what you'll do. This is the brute force approach. I hope you people have understood like what is the tedious task that we're doing. So the time complexity in this case is O of m into n. Why is it that so? Because we are doing the checking task. What is the checking? So you are comparing each and every element. This is basically O of m into m, because two rows we are checking for this for the all the rows, right? We are checking this task for all the rows. And how are we doing it? We are actually making sure that we are doing it for n number of times, because there are n number of columns, so we are doing it for n number of n times, that's for sure. So that's the reason the time complexity is O of m into n. I hope you people have understood. So this is the same checking task you're doing for all the combinations of rows, right? So that's the reason it's O of m into m. And how many number of times you're checking? Because there are n number of columns, you're doing it for into n number of times. That's the reason O of m into n. This is the brute force approach, right? This is the brute force approach. Now what is the optimal approach? So in like, if you can actually correlate this problem to your in our daily life scenario, the problem is actually asking like, in case if you're trying to relate, it's asking like, if I can find a duplicate of you or me or anyone of my friend or my parents or my children or my sorry, no children, my brother or sister or something like that, if they can find a duplicate, then I will take their address or phone number or something like that. That is what you can relate the problem to. Now how you'll do a final legit check, or what do you say, that is a pure legal check, by taking the Aadhaar card number, isn't it? You will take the Aadhaar card number of me and some other fellow, and if that appears to be same, that comes up to be same, that means he's a duplicate of mine, isn't it? So I can come to that conclusion, right? So Aadhaar card number is a unique identification number, right? It represents me. It represents, that number is actually me, isn't it? In terms of number. That same thing we can also apply here. The same logic we can also apply here. So 100, why don't you convert that into an identity or into some term that is unique to 100? So what you could do, if you could say like your ideas might be like, okay, I'll add these numbers. So if you can add these numbers, the result you'll be getting from here is 1. But what if there is a row like 001? What if you add the numbers of this row? You'll be getting 1. So the 1 is same in this case and in this case. So will you conclude that this row and this row is same? No, because this row is 001, this row is 100. So addition of numbers in a particular row cannot give you a unique result. So what is the unique result that you can get? So in that examination, you can clearly come to a conclusion within just minutes that 1 0, these are all bits, right? These are all bits. So a binary representation will be unique to every decimal number, isn't it? No two decimal numbers will have same binary representation, and no two binary representation will have the same decimal number, isn't it? So why don't we convert this binary stuff that is there into a decimal? So this would result in 4, this would result in 4, this would result in 0, this would result in 0, the whole row I'm talking about, right? So in that case, this 4 has been repeated once again. That means this row is a duplicate, right? So 100 has appeared already before. That is a small logic that you can come up with. So if you can convert all these rows, the numbers that are there, into row elements into binary representation, that can give you a perfect clarity, like whether it's being repeated for twice or it's appearing for the very first time, right? So that is the small logic that is there. Or another way to do is convert this whole thing into a string. So if you convert this whole thing into string, you'll be getting 100. This is also 100. So you can just check if this string has appeared once again in, like previously, this string has appeared previously. So you can even do that, right? So I hope you people have understood. So for this reason, we are using a set. Okay, so set will store all the final results. If that result, if like after at this particular 0th row, I'll be in my set, I'll be having 4, because this representation is 4. And then when I comes to the first row, I'll be checking if after checking the evaluating this comes out to be 4 as well, right? I'll be checking this 4 is in there in the set. If it is in there in the set, that means it's coming for the second time, right? So I'll not be putting that into my set, I'll be putting that index into my vector. If it is coming for the first time, I'll be putting it in the set, right? That is a small logic. I hope you people have understood. So the same thing I've put in the code, right? The same thing I've put in the code. And this time complexity, for this optimal time complexity, what is the time complexity? Because you are storing, what are you storing? The final result, and each row has its result, right? Each row has its result. So the space complexity in this case is O of m, right? Because in the worst case, all the rows will have different different final values, right? If all the rows are different, so that's then we'll be having m values in our set. That's the reason the space complexity is O of m, right? I hope you people have understood. And the time complexity is very evident, that is O of m into m, because we are traversing every value, that is for sure. We are traversing every value, so that's the reason it's O of m into n. That is the time constants. So let us go through the code now. So going through the code now, so we have first taken an unordered set. and then a vector int. So just to take the indices of all the required rows, and then we have traversed this particular matrix. So what we have done is, first we are trying to convert the particular row into a decimal, right? So we are trying to convert the binary to decimal. That is our first task that we are doing. So how are we converting this particular thing? So when we have a particular matrix of ij, so we are doing that left shift with the j. So what is the j here? J denotes the column. So how is this being helpful? So if your matrix of ij is basically 0, will that have any impact or effect to the final answer, final number? No, it will not be having any sort of contribution. But what if matrix of I of j is 1? So then it will have a contribution. So that's the reason we are doing that left shift with that particular column number. So for example, if you are taking this condition, I mean this row 100, okay, 100. So this is the 0th row, this is the first row, and this is the second row. So what is this number actually in binary decimal thing? It is 4. But how are we getting it? So this 1 is being left shifted for twice, right? So that is what we are doing. So this, when it comes to the 0th column, it is 00, 0, that doesn't have any impact. And then coming to this, it will be 0 left shift 1, that will not have, that will also not have any contribution. So but when it comes to 1 left shift 2 gives a contribution, that is actually equal to 4. I hope you people have understood this logic. So this is the conversion of binary to decimal. So wherever you find 1, left shift that with that particular column number, so that you'll be adding that final result into your answer. So that gives your final decimal representation of that whole row. And now once you have done that, you'll be checking if that particular number is already there in your set. If it is there, that means it is a repeated row. So and insert that particular, I mean, if it is not there, that means add it to your set. Else if it is there, then put that index, particular row index, into your vector answer, and finally return that answer. That's it. I hope you people have understood. I think I've already submitted the code. It must run successfully, but I don't know, like, internet connection is working. Yeah, it's working fine. So I hope you people have understood this thing logic. For your reference, codes in C++, Java, Python are there in the description. Please go through those codes. And also I've created a WhatsApp channel, guys, for posting off-campus opportunities. You people can have a look into it and join if you are in a need of it, right? So thank you guys for watching this video. Stay tuned.